All right, so we're going to look at the metric system and dimensional analysis quite a bit here. We'll take a couple days to work on this, obviously. So metric system, it's base 10 measurement system, mass kilograms, length meters, time seconds, volume we use liters. In the SI system, they use cubic meters. I like liters better because most things we deal with will be in liters and milliliters. So those are the base 10. Those are the four main measurements that we're going to be concerning ourselves with. We use prefixes to show powers of 10, and we use the metric staircase to convert between these prefixes. Now, the metric staircase looks like this. You have your base units, and then you have down the staircase, which is smaller, so decimeter, centimeter, millimeter, etc. And you got micro, you got nano. And then from base, you go up to kilo, then you go mega, then you go giga. We're really going to concern ourselves from kilo down to milli, but micro and nano will come up. And so as we talk about the staircase, just understand that you want to have this whole thing in front of you when we do things. And you'll see on the practice how we do. But usually kilo through milli is what we measurement. But micro and nano do come up, all right? And in this document gives some examples. But I'll give examples to show you how to use this, okay? But this will also be on the agendas. So the first thing we're going to do is talk about how to do these conversions using the metric staircase. Do it now. Okay, we're going to do conversions using the metric staircase. This is kind of an abbreviated staircase. The one you see on the earlier in this video, and then also it'll be linked in different places that you can access it. Usually in the agenda will be the best place to go. I would write that on my periodic table just as a reference until you start to memorize it. So anyway, we're going to start with 36.52 milligrams. We want to go to grams. So when we look at the metric staircase, remember our base unit, grams, meters, if we're talking times, seconds, and among other things. It would just depend on what unit that we're talking about here. In this case, we're talking grams. So we're going from milligrams to grams, okay? So I start at milligrams, and I want to go to grams. So I go 1, 2, 3 to the left. So then I move my decimal, 1, 2, 3 to the left. So this is 0.03652 grams. We got kilograms. We got kilograms to milligrams. So I got 14.72 kilograms, and I want to go to milligrams. So I go to kilo, and I work my way down to milli. So I go 1, 2, 3, 4, 5, 6 to the right. So I'll move my decimal. 1, 2, 3, 4, 5, 6. Okay, and you can see I put commas in there. So 14,720,000 milligrams. Now let's say I go kilometers to decimeters. All right, so I start off here, and I go from kilo to deci. I go 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the right. The answer's 35. Meters to kilometers. So now, let's say I don't have a prefix, right? It's just M, meters. That's going to be base, and I'm going from base to kilo. So I go 1, 2, 3 to the left. 1, 2, 3. 0.00134 kilometers. And then we want to go from millimeters to centimeters. So I write down 25. If there isn't a decimal on the number, I know where it's going to be. It's going to show up here at the end. And I'm going to go from milli to centi, so I go 1 to the left. And my answer is 2.5 centimeters. Very quick way to do conversions. Again, we can work our way up to like mega and giga, and we can work our way down to micro and nano if we need to. But this is the base of how the metric staircase works. If you have issues, please ask, especially if we get higher and lower. But again, you just go where you start to where you finish and move your decimal. All right, so now we have conversion factors. A conversion factor is anything that's an equality. So for example, 1 inch equals 2.54 centimeters, which means we can say 1 inch divided by 2.54 or 2.54 divided by 1 inch. Now why we can do that If they're equal, it's like saying two numbers equal. So 3 equals to 3. So 3 divided by 3 equals 1. So if 1 inch is equal to 2.54 centimeters, 1 inch divided by 2.54 centimeters is also equal to 1. So when we use conversion factors, we're using equalities. And in math, all we do with those is multiply by 1. And I'm going to show you how it's done. But there's our conversion factor. The first two conversions we're going to do are how many centimeters in 6 inches and how many inches in 24 centimeters. Do it now. All right, so quick conversion. We said 1 inch, and 1 inch is equal to 2.54 centimeters. I can write it either 1 inch over 2.54 centimeters or 2.54 centimeters over 1 inch. It doesn't matter since they're equal. You divide them by each other, it equals 1. So our conversion factor always equals 1. So if we have an equality, we can make a conversion factor. So I start at inches, and I have 6 inches, and I want to know how far that is in centimeters. So I know 1 inch is 2.54 centimeters. When I do a conversion, if inches is here, I want inches to be diagonal from it in my conversion factor. So I want inches on the bottom. So 1 inch is 2.54 centimeters. That allows my inches to cancel, and my answer will be in centimeters. So now, mathematically, when I look at this, I say that I take 6 times 2.54, and I get 15.24 centimeters. Now, once I multiply by the top, I divide by the bottom, I divide by 1, which is still 15.24. But now I look at my sig figs. I always look at my first number, 3 sig figs, so I want to round this to 3 sig figs. So my answer is actually 15.2 centimeters. Now let's go the other way. Let's go from centimeters to inches. So I have 24 centimeters, and I want to go to inches. Again, they're equal. But since centimeters is up here, I want centimeters down here. So I'll use this conversion factor, and I'll say 2.54 centimeters in 1 inch. Now, since it's on the bottom, I will take 24 divided by 2.54 and hit equal. And I get 9.448818, etc. I look at my first number here, 3 sig figs would be here. 8 tells me to round up. 9.45 inches. So the answer is rounded to the correct number of sig figs. All right, our next conversion. How many seconds in 2 years? Do it now. All right, so I want to know how many seconds there are in 2 years. Now, not everything is going to require us to know science facts. It could just be normal things that we know. So we want to go from years to seconds. So we think about things we know. We know 1 year, it's 365 days. Now, if we want to be specific, we'd say 365 and a quarter because of leap year, but 365 will work. Okay? We know 1 day is equal to 24 hours. We know that there are, in 1 hour, there are 60 minutes. And we know in 1 minute, there are 60 seconds. So now I can go from years to seconds just using facts that I know without having to do a whole lot of fancy math. So let's work through this. So I have years, so I want years down here. So my conversion factor is this. So I say 1 year, so years cancel, 365 days. Now I got days, and I've already used this conversion, so let's go see. This one has days. 1 day, 24 hours. Days is here. I go 1 day. 24 hours. Now I'm at hours. 1 hour is 60 minutes. I have 60 minutes. And then lastly, 1 minute, 60 seconds. Since minutes is up here, I put minutes at the bottom, 1 minute. 60 seconds. And then I go through and solve. So I take 2 times 365, I hit equal, times 24, I hit equal, times 60, I hit equal, times 60, I hit equal, and I get this number. Now looking at this number, I look at my first number here, 1 sig fig, so I want to round to here. The 3 tells me to leave it alone. I put a 6, but that's in the 10 millions place, so I have to drop 0, and 2 years is 60 million seconds, rounded to the correct number of sig figs. What is the density of mercury? So 13.6 grams per milliliter in units of kilograms per liter. And I'm going to show you how to use the metric staircase to make conversion factors. Do it now. Okay, so a conversion here with density units. I have 13.6 grams per milliliter to kilograms per liter. And this gets kind of crazy when we write this out. So I'm going to write this out and say 13.6 grams per milliliter, okay? I want to convert from grams to kilograms, and I want to go from milliliters to liters. So let's go grams to kilograms first, okay? And I know if I do a conversion, I'm going to have grams at the bottom, kilograms on top, so they cancel. So here's how we make a conversion factor for the metrics. I look at this, all right? And I say grams is here, kilos here. Grams is below, kilos high. Whichever's highest up on the stair step in our conversion factor gets a 1. So 1 kilogram. And then I see how many grams. I count down 1, 2, 3. I go 3 zeros, 1 in front, grams. 1 kilogram equals 1,000 grams. So there's my conversion factor. I put 1,000 grams here, 1 kilogram on top. Grams cancel. So now I want to go from milliliters to liters. Milliliters has to be on top so it cancels. Liters has to be on the bottom. So liters would be a base because it's by itself. Milliliters would be down here. Liters is higher up, so I say 1 liter is equal to, and I count down, 1, 2, 3 zeros. Put a 1 in front, milliliter. Substitute the numbers in, 1 and 1,000. Oh, not kilograms, sorry. Liters, milliliters cancel on everything, and liters stay. Kilograms per liter. So I think 13.6, so I get my calculator out. Some of you that are math people are going to see this answer before I do. And I go to this box. This box, it's at the bottom, so I divide by 1,000, hit equal. And then this box, I multiply by 1,000, hit equal again, and I get 13.6, and my answer is kilograms per liter. But this is how you get conversion factors using the staircase. And then our last one, we're going to convert 35.6 meters per second to kilometers per hour. Again, using the staircase to make a metric conversion factor. Do it now. Okay, so let's practice another conversion. I got 35.6 meters per second, and I'm converting it to kilometers per hour. So this would be like a rate problem, an acceleration or a velocity problem. But 35.6 meters over seconds is how I start. I want to go from meters to kilometers, and I want to go from seconds to hours. I start on top, so I go from meters to kilometers. That's metrics. I use the staircase. Meters equals kilometers. Kilometers is here. Meters is here. So since kilometers is on top, I put a 1 here. Then I count down the stairs to get to meters. 1, 2, 3. 3, put a 1 in front. So there's 1,000 meters in 1 kilometer. When I put the conversion factor here, since meters is here, I want meters down here, so I put 1,000 meters in the bottom and 1 kilometer on top. My meters cancel, and I'm halfway there. I want to go from seconds to hours. Now I have to think back to what I did before. That's not a metric, it's what we know about time. And I know there are 60 seconds in a minute. Seconds is here, so I put seconds up here, so I go 60 seconds in 1 minute. But I want to get, not minutes, I want to get to hours, so I want to go from minutes to hours. There are 60 minutes in 1 hour. Since minutes is here, I want to put minutes here. 60 minutes to 1 hour. And now I have kilometers over hours, now I can solve. So I go 35.6. Since it's on the bottom, I divide by 1,000, hit equal. Since 60 is on top, I multiply by 60, I hit equal. And since 60 is on top, I multiply by 60, I hit equal. And I get 128.16, 3 sig figs, so I round here,